So welcome everyone. You have reached, I think, one of the most exciting weeks of the course. This is when you are going to start to dig into the structure of groups. So you saw last week, one of the most important tools that we have as group theorists is the isomorphism, because it tells us that we don't have to study every single group in existence. We can just study the structure behind groups that are the same from our perspective as group theorists. And so this week, we are really going to start to dig into the structure of groups. And you're going to start to see what we mean by looking at the structure. Now, there's going to be at least one observation that you will probably not find surprising. But there are other things that should at least strike you as beautiful, I think, if not surprising, at least beautiful. So what I want you to do during this video is just look at some Cayley diagrams, follow along with me as I'm going through Group Explorer. And then after, look in Group Explorer yourself. And then I'll preview some of the readings that we have for this week. So I'm going to be looking at some Cayley diagrams and multiplication tables. And maybe I'll start off with S3. So S3, as we saw actually in the isomorphism week, is also called D3. So symmetric group on 3 letters. It's the same thing as the dihedral group of order 6. So we don't know what a cyclograph is, actually. You're going to learn that this week, or you're going to at least kind of understand it a little bit better this week. But we're going to be interested in the Cayley diagram and the multiplication table. So let's look at the Cayley diagram first. Okay, and I'm going to pay attention to the side panel that we've been ignoring a little bit, where it lists all of the subgroups. So if I right click on any of the subgroups, I'm going to get a couple of options, and one of them is this. So let me look. I'm going to start by looking at H4 that's generated by R, the subgroup of order 3. So first of all, I'm just going to create this. So these are, oh, actually, no, I don't want to create it. Never mind. Sorry. I think I'm just going to compute it first. Yeah, let's just compute it. So let's compute the left cosets of H4. Okay, so the cosets are going to be defined precisely in your reading, but let's just see what they look like for now. And we're told that it creates something called a partition. And a partition is just a division of the nodes into sets. So we have 2 different sets. One is the identity times our group. So it's just our subgroup, E, R, and R squared. And if we want, we can highlight that subgroup. And then the second one is the flips times H4. So if we take all of these members, multiply them by the flips, we should get all of those inner items, which we do. Okay. And then maybe a shortcut, which I'll actually use more often, is to highlight the partition. So this is going to highlight the 2 sets, 2 different colors. Okay, so we've been really paying attention to the subgroup, but you've probably noticed, and I think I've pointed out a couple times, that there's also copies of these subgroups sitting inside. So this is a pretty obvious one, but we might ask about, other ones. This one's maybe not so obvious. So I'm going to compute all left cosets here, and then I'm going to highlight the item, or I'm going to highlight the partition by the node color. Okay, and then this time I have a partition that isn't as natural. So the original subgroup was H3, which is just the identity, and RF. So it's these red nodes. they're separated, but they're still a subgroup. Anytime I have the identity and one other element, they're going to form a subgroup of order 2 if that other element has order 2. And so we also see that we have this same, we have a way now, there's like kind of a mathematical way of reflecting the fact that we have copies. Kind of turn that subgroup, in this case, by 1/3 of a full turn, and we get other copies. Okay, and we can do that for all of these different subgroups. So let's look at something maybe a little bit different. Let's look at Z6. Okay, so in Z6, we have a subgroup of order 3. So again, we can compute the left cosets. These are cosets, and we can highlight the partition by that. And this is itself a subgroup of order 3. And there are 3 items left, and they also form a set of order 3. It can't be a subgroup because it doesn't include the identity, but it has a special relationship to that original subgroup. It's everything in the original subgroup multiplied by A. And then before we leave Group Explorer, I also want to point out that we can do a similar thing in Cayley tables. Maybe I'll go back to S3 and look at the Cayley table. So I can highlight here we go. I want to compute the left cosets again. That can allow me to do that, yeah. And then I can right click here and highlight the partition. So I'm going to highlight it maybe by the border this time. Okay, no, that did not work very well. Let's not highlight it by the border because that, the background. Okay, so here we have things that are in different partitions are highlighted different colors. Now in this case, it looks like it's all over. What is the pattern here? So in order to see this pattern, we need to organize the table a little bit differently. Now notice that these are cosets of H1. So if I go to my table, I can organize this by subgroup. So let's organize it by subgroup. H1. That didn't work so well. That did not work as expected. Let's go back. H1. And I organized it by H1. A flip. Oh, I know it's a little bit weird here. So I organized it by H1, but yeah, I organized it by H1, but the issue is that H1's so small, it's only 2 things in it, that there's like still a lot of extra movement for the order of those elements elsewhere. Okay, so I can still have individual elements in different cosets. So you see these like red elements, E, Fs, the E's and Fs are in different cosets. But as I pull it apart, I get the different cosets. Yeah, that's still different than what I expected. And I'm probably not going to delete this part from the video because this is still a learning moment. This is still a little different than what I expected. Yeah, let's recolor. I'm going to recolor this and just default. And if I go to the table right away and I organize by the subgroup, it looks like this. Yeah, and I think that the issue is that it's still such a small group that I'm not seeing patterns as strongly as I would if I organized it by, say, H4. And I'm seeing, I need to look at the elements as a whole in the blocks, not how they are arranged in the individual blocks. So they might be totally mixed up within those blocks. So it doesn't matter how they're arranged within the blocks, it just matters that they are in the blocks. So if I go back to H1, then I have yellow, green, blue, and reds together. And then purples. Okay, I know what's going on. Okay, so this is a good example that sometimes we have cosets that don't work well together. We still have cosets, but they somehow are not working as nicely as this type of coset, right? We have them kind of mixed up. And so this is a condition that we're going to talk about in the next part of our study of cosets. Yeah, and normally we don't look at these ones visually because they're kind of messy, but we still get a nice separation. We still actually get a coset. And if we look at the same one, this H1 in a Cayley diagram, so going back, I think S3, yeah, H1's labeled the same thing. I'm going to compute the left cosets again. And now I highlight the partition. Okay, so they look pretty nice here. On the diagram, but somehow the table is showing us that when we actually go to see how they interact with each other, when they see how they play well together, something's a little bit different is happening maybe. Okay, so that's food for thought for next week. I introduced it a little bit too early inadvertently, but what I want you to get out of this is being able to just visualize these things and seeing that no matter what subgroup we choose, we can always chunk off parts of our group by the subgroup and its cosets. We have like copies of the subgroup throughout the group. So for your reading this week, you only have one main reading, and that is in the Gallian text. So this is the chapter on cosets. There are some supplementary readings that I really encourage you to take a look at if you don't quite understand this. So the supplementary readings will cover the language of partitions from a more technical point of view. That's from chapter 0 of your textbook. Also, there's a reading on the Cayley diagrams and how this all interacts with Cayley diagrams, because for me and for every student that I've worked with, the visual element is really key to understanding the algebra. We can see the algebra as well, and you definitely want to be able to do that, but seeing it gives you some intuition. And then there is also some really nice applications at the end of the chapter. And I don't think I'm going to assign those as required reading, but they are really, really good and very interesting. So I highly encourage you to read those as well. Okay, take care. Enjoy your reading this week as you build up your group theory skills.